Applications of thermogravimetric analysis. The first application of thermogravimetric analysis is in the determination of purity and thermal stability of primary and secondary standards. Thermogravimetry is a valuable technique for the assessment of purity of materials. Many primary standards like sodium carbonate, sodium tetraborate, and potassium hydrogen phthalate absorb moisture when exposed to moist atmosphere. Thermogravimetric data shows the extent of this absorption and hence the most suitable drying temperature for a given reagent may be determined. The thermal stability of EDTA and its disodium salt has been reported by Wendland. He showed that the dehydration of disodium salt commences between 110 degrees centigrade and 125 degrees centigrade, and it could be safely heated to a constant weight at 80 degrees centigrade. The second application of thermogravimetric analysis is in the determination of correct drying temperature. Thermogravimetric analysis is widely used in qualitative and quantitative analysis. Much work in thermogravimetry has been done to establish optimum temperature ranges for the conditioning of precipitates for conventional gravimetric analysis. In the figure shown, the thermogram of calcium oxalate, calcium oxalate is normally precipitated as the monohydrate from hot solution. The curve shows several plateaus corresponding respectively to monohydrate from room temperature to 100 degrees centigrade, anhydrous calcium oxalate from 226 degrees centigrade to 398 degrees centigrade, calcium carbonate from 460 degrees centigrade to 635 degrees centigrade, and calcium oxide from above 840 degrees centigrade. The calcium carbonate is in excellent weighing form if it is heated to 500 plus minus 25 degrees centigrade. The second curve represents the thermogram for magnesium oxalate. The third curve represents the thermogravimetric curve of silver chromate. In the silver chromate curve, the initial drop in weight indicates the excess water, and just about at 92 degrees centigrade the weight becomes constant and remains so up to 812 degrees centigrade, after which oxygen is lost. The decomposition of silver chromate can therefore be represented as 2Ag2CrO4 gives Ag2Cr2O4 plus 2Ag plus 2O2. Silver chromate is thus stable over a temperature range of about 90 degrees centigrade to 800 degrees centigrade. Hence, in gravimetric analysis of chromium, the precipitate of silver chromate can be dried anywhere in this region and weighed at a temperature of 135 degrees centigrade. The next application of thermogravimetric analysis is in the evaluation of suitable standards. Duval, with the help of thermogravimetric studies and IR studies, confirmed that lithium sulfate monohydrate, sodium dichromate dihydrate, sodium cobalt nitrite, hydrazinium chloride or sulfate can be used for preparing standard solutions, while magnesium ammonium chloride, ammonium bicarbonate, and ammonium fluoride are not suitable for preparing standard solutions. Determination of Curie point. If a ferromagnetic substance is kept on a thermobalance with the pole of the magnet above the sample, the thermogravimetric balance will show the weight which is less than the real weight without the magnet. If the sample is now heated above the Curie point, the ferromagnetic properties of the substance will disappear. This property is used to determine the Curie temperature of ferromagnetic substances. Thus, a thermogram of a sample is, if recorded in presence of magnetic field in the thermogravimetric curve, the temperature at which the thermogram shows an increase in weight is the Curie temperature of the sample. The next application is the analysis of mixtures. In the above figure, the curves of calcium oxalate and magnesium oxalate reveal a significant difference in behavior between the two oxalates, that is the calcium and magnesium, which can be seen from the decomposition reactions. Magnesium oxalate does not pass through the carbonate stage. This difference in their thermal behavior permits their simultaneous determination by thermogravimetric analysis. Calcium and magnesium oxalates can be determined in a mixture by igniting at two temperatures. At 500 degrees centigrade, the calcium carbonate and magnesium oxide are stable, while at 900 degrees centigrade, both metals exist as simple oxides. The weights of a mixed precipitate at these two temperatures will permit calculation of both calcium and magnesium contents of the original sample. The next application is in the analysis of alloys. The thermogravimetric analysis of copper-silver alloy is based on the relative stabilities of the nitrates. Duval has simultaneously determined the copper and silver content in the alloy. When we study the TGA curves, they indicate that silver nitrate is stable up to 475 degrees centigrade, after which it loses nitrogen dioxide and oxygen, and the weight becomes constant above 608 degrees centigrade when it is converted into metallic silver. Cupric nitrate, on the other hand, decomposes into copper oxide in two steps. CO is stable above 700 degrees centigrade. Thus, the weights of the mixed precipitate at 400 degrees centigrade helps to analyze copper-silver alloy. The next application of thermogravimetric analysis is in the kinetic studies. Thermogravimetric analysis can be used to study kinetics of a chemical reaction and to determine basic kinetic constants such as the rate constant, activation energy, order of reaction, and frequency factor. In these methods, a change in some physical property like weight, enthalpy, length, or volume as a function of temperature is measured automatically. The reactions involving change in weight are used to study reaction kinetics. The next application of thermogravimetric analysis is in the measurement of surface area. Solid surfaces adsorb gases. So the gas adsorbed on the solid surface contributes to its weight. Thermogravimetric analysis can be applied to determine the gases, for example, nitrogen. In a conventional method, a cleaned sample surface is thermostated at the desired temperature in a thermobalance, and a gas at the known pressure is allowed to be adsorbed slowly. The weight gain with time is recorded. After the equilibrium gets established, the pressure is increased to the next desired level. This method is used to obtain adsorption isotherms.